So this is going to be a quick demo and overview of the VirtualEdge system. Overview the host system, the configuration, the networking for the host, the networking for the client, and then go through the whole install process on a live system, which should be here. Yep, there we go. So this is my test system. The host system should be at least 16 gigs of RAM, 4 cores, and at least 150 gigs of disk space on the host itself, because each Edge instance will need at least 8 gigs of RAM, 2 cores, and 120 gig of space on the host system. If the host system only has 120 gigs, it is not going to be a good setup, because the VirtualEdge instances can expand up to 120 gigs themselves. My demo is being done on a quad core system with 16 gigs of RAM, 480 gigs of disk. It's a pretty small system, but it runs without any issues. Before you can bring up the VX system, you'll need an account on your host with sudo or root access. You'll need a QEMU compatible hypervisor installed. We use KVM and libvert, and we'll install that as part of this. I'm demonstrating using Ubuntu 22 long-term support server. Each VX instance will be set up with one LAN port, and an admin interface. Multiple VX interfaces can share a WAN interface because they'll just look like separate clients. They can also share an administration network if one is set up with DHCP. Each instance should have a dedicated LAN port with a network bridge configured, and we'll go through that as part of this. So we'll start by doing the hypervisor installation. And I'm going to be cut and pasting a lot of commands here, but that's just to make this go faster. So just to make sure I have permission to be able to do that command, I had to have valid sudo access. I had to be able to run as root. So now I'm going to paste the installation of the hypervisor. This will install all the necessary tools and packages to bring it up, and then it'll start libvert. This will take a couple of minutes. This is normal. This is just part of Ubuntu's thing, and we can just say that's okay. We don't need to. It will all work without a reboot. So, and now install some of the other packages. This host is just Ubuntu server fully updated. All right, now that's done. The next thing we need to do is we need to make our user able to run commands in the hypervisor. So we will make him part of the KVM and libvert groups. And that's important because otherwise the hypervisor is normally only accessible to root. So now we should be able to run. Virsh is the command line tool for managing virtual machines in KVM, or actually technically libvert, but whatever. And this command lists any running VMs. Obviously, we don't have any because we haven't started any yet. And now we will deal with the networking. This is where it can be complicated depending, or a little bit, may require a little bit of admin research depending on what host OS you're using. You have to create a network bridge on the host. It's done differently depending on the host OS. Ubuntu Server uses NetPlan to manage its networking. Ubuntu Desktop uses Network Manager, and they work completely differently when you're trying to create a bridge. Other distros, Debian doesn't use either one. Fedora doesn't. So you have to kind of figure out what we're going to be doing. We have to create the bridge in the host OS and then make it visible to the hypervisor. And I'm going to do that with NetPlan now. So we have to create a NetPlan file, and that's done in etc NetPlan. And this is specific to my system, these settings. But so what this will do is it will create a bridge named BR0 with physical interface EMP4S0 attached to it. That's going to become my LAN port to the outside world. So this will become this physical interface on the host will become the LAN interface for the virtual system, and we'll associate those in the next step. So we'll save that, and then we will apply the NetPlan. And okay, good. If you get the NetPlan wrong, you can accidentally lock yourself out of the box. So be careful doing that. Otherwise you can mess up the networking to the point where it becomes not working. So now we need to make this bridge visible to the hypervisor. Create an XML file, which defines the bridge name. Apparently I can't do VI today. There we go. And then we have to create that in the hypervisor using Virsh, using the netDefine command and giving it the XML. So now it's defined the bridge. So now if I look, we can see that it's there, but it's inactive. So we'll start it and we'll set it to auto start when the system boots. And if we look now, it's all set up. So now we need to download the software and everything. So I'm mostly following this. I'm not necessarily following it in order. I apologize. So we need the VX image itself, which is a QCOW2 format file. I've already downloaded it. You get that from Portal, Software Configuration, VirtualEOS, and you download. If I were to do this from our laptop here, it would take like way longer than we need to deal with. So I actually have the blank image here. This is the downloaded from the site. And I also have a reference definition, which is important. That is actually, there's a link to that. Here it is. You need this file to create the VM. So we've got this downloaded. We need to create a copy. First, we need to unpack it. So we'll do that. This will take a minute. It's a 4 gig file that'll decompress to about 8 gigs. So now I already know what VX license I'm going to be using, and I'm going to be using VXDID 999991 for this. So when I create the copy, that's the name I'm going to use for it.
So you got the license from the
Yes,
service?
I already have my license set up. It's my test license.
Okay.
That process is all described farther up here. But you do have to have a registered device license, a registered device ID before you'll be able to do this. Okay, all right, so we're unpacked. I'm going to make a copy of this. So this is here, step 4. You create a copy of this. I'm copying it straight into varlib. This is by default, this is where libvert stores all of its virtual images. That doesn't mean it has to be there. If you want to set up virtual machines on a separate disk device, you can do that. It's not particularly difficult. You can look up you'd have to look at the documentation, but it's not bad to do. So we'll copy that over. Again, it's a multi-gig file, so it's going to take a sec. There we go. And now we will copy this file. And I'm doing that locally because I don't need to make this accessible to anything. I'm going to use Versh to load it in. Actually, I will use Nano for this because Nano is easier for people to understand. So now we are going to be doing, so that was step 5, copied the XML. And now we're going to do the edit step. This is where people have gotten hung up, so we definitely want to understand what we're doing here. Basically, in this file, if you see where it says change, that's what you should do. That's a place that you probably need to make an edit. So here, this name is what it will look like in the Versh command list, or in the Vert Manager if you connect one. So we want to change that to something that we can understand. I usually use the serial number just because that's what I work with. Memory and CPUs are defined here. You normally wouldn't change these. This is strictly for the hypervisor. So here we have to tell it where we stored that image. So one too many slashes there. So this is where I put the copy of the QCOW. Don't need to change any of this. So we'll go back, so we'll go down until we find the next place that says change. This is the network setup. So here you need to change this to the host interface name. And in my system, that is P5S0. Here we put in the name of the LAN bridge that we created, which was BR0. And here we put the administrative interface, which is P1S0 in my system. This interface is set, this line here, link state down. This means the interface will be disabled by default. And I do that, it's that way so that it will, if it doesn't get a DHCP address, it will start a DHCP server. So I default this to down to avoid conflicting something else on the network. If you're not going to try to connect to the administrative interface, that's fine. And most of the time you don't. This is what defines what the host will expose to the guest for network interfaces. And those names will be determined by Linux consistent naming doctrine based on the PCI information. Minor sidebar, ENP5S0 is PCI ID 5 device 0, slot 0. That's where how these numbers are derived. It's a network PCI device bus ID 5 slot 0. So what this line does, this is why, so because this bus is 1 and the slot is 0, it will come up as ENP1S0 every time you define a VM using this statement. Again, this is what's exposed to the virtual hardware. This is the virtual hardware that the host is going to create and expose to the guest. And then the Linux OS that's running in the guest is what actually will do that side's predictive naming, consistent naming. And then, like I said, we have additional interfaces here if you need them. And that's basically everything we need to change. You set the name, you set the disk path, and you set the network interfaces. After you install the hypervisor, reboot. Right. So now it should. That's just the KVM to the box. I'm just going to keep an eye on it and see when it's done rebooting. Okay. So now if we look, there it is. So now we'll tell the hypervisor to start the virtual machine. And now it's going through the standard Linux boot up sequence. So now we're at step 9, which is we'll need to do the configuration, the personalization. To do that, I'll use the serial console. All right, so the VM is up and running. There. All right, that's normal. It's setting up the internal networking, so we'll give it a minute here. So the first interface we select is management. The system will try to pick the one it thinks is the right one. By default in the XML, it would be EMP3 because it was the third one we defined. So that's okay. LAN interface, EMP1, yep. LAN interface, EMP2, which is correct, also correct. And the reboot cycle can take a little bit. We'll get back to since I didn't disconnect the serial console, it will come back up to the login prompt when it's finally back up. And so that's what I just went through is this section. This has more interfaces listed because somebody defined these three, which are the additional WAN and LAN interfaces. And you can actually select multiple LAN and WAN interfaces, obviously. I don't need to do any IP definition because my WAN is set up for DHCP. All right, good. Log back in. And now I need to register the system. And this could, yeah, again, we're bringing up the network interfaces, so we'll have to give it a minute to get an outbound connection. Obviously, to register the system, you have to have a valid outbound network path on one of the WAN interfaces because it has to reach the registration servers. Yeah, this was just explaining some of the network. It's the whole naming thing. It can be really confusing because your host might have interfaces named this as well as your guest, and they're not the same interfaces. All right. All right, so now I've logged in with my sport credentials, and this is the license I'm going to assign to this device. This is my key. Yes, because that VM was deleted. And now we'll reboot again and bring that up. And do that. Okay, so the system's finished rebooting. So we can disconnect from that. And now I'm actually watching Connect. And I might have to restart Connect before it'll pick it up, but we'll give it a couple of minutes here and this should come up online. At which point I should be able to open the portal. I'm using Connect because it's an easy way for me to get to the admin. Since I intentionally didn't connect the management interface so that it would follow the way that it's set up. I'll probably need to restart Connect for it to pick up that server. It can take like 10 minutes, so. See here that it is actually come up and it's connected. So we can start this. And there we are. That's it, it's up and running. Yep, at this point, software updates and upgrades will occur normally. It works almost identical to our standard system or to our physical systems. And one thing to keep in mind is that it depends a lot on your host as to what your overall capacity will be.